Hello, this is the last of the problems, number 4, from the Newton's second law practice problem worksheet. In this problem, we have what's called actually a modified Atwood machine. It's essentially two objects connected to each other via a pulley. So you might have a table, and at the edge of the table is a pulley. The idea of the pulley is it just makes it easy for a rope to slide. And on either end of this rope are two boxes, and the diagram labels this A and this B. Now in our problem, we're simplifying it, saying there's no friction anywhere in the system, and we are given the fact that the mass of A is 15 kilograms and the mass of B is 30 kilograms. Before we start solving and analyzing the system, I want to point out what's really going on here. When this system is released, the weight of B will pull the entire system meaning A and B, down into the right. So the concept here is that the weight of B drives the system. The weight of B will accelerate, or accelerates, both mass A and mass B. This is key to understanding this question, because our question is calculate the acceleration of each mass. Well, because they're tied together by a rope, and I'm going to assume that that rope does not stretch, the masses will actually have the same acceleration. So the next idea to grasp is that the acceleration of A is the same as the acceleration of B. They move together. So I could actually think about them as a combined object. As a single 45 kilogram object. So now if I want to calculate the acceleration, I'm actually going to go straight to Newton's second law. I don't have to do a whole lot more. A from second law is the net force divided by mass. Net force divided by mass. Well, in this case, I'm talking about the mass of the whole system. The mass of the entire object is 45 kilograms. And what is the net force that drives that whole system? It's simply the weight of block B. The weight of block B is going to be its mass, 30 kilograms, times 10 meters per second squared. Some of you may be wondering about negative sign here. That's a good question. We can talk about that in a second. But let's finish this calculation. I'm going to see that the acceleration is 6.67 meters per second squared. Now in terms of direction, for block A, the acceleration is positive or to the right. In B, the acceleration is negative or down. Now, it may seem bothersome that one calculation yields accelerations in two different directions, but that's the whole point of the pulley. The pulley allows the two boxes to accelerate in different directions while being tied to the same string. I want to also point out that this value, so we can box that, that's our final answer. This value works out to be 2/3 of g. And that 2/3 function is important to note. That 2/3 fraction, I should say, because really what we have is 2/3 of the mass of the system creates the force W of B to drive all of the mass that's MA plus MB of the system. In other words, 30 kilograms generates a force of 300 newtons that is responsible for moving not just its own 30 kilograms, but 45 kilograms because of the additional freeloading, if you think about it, freeloading mass of 15 kilograms. And this is the end of practice problem number 4.